All right. So as I had said, it's not feasible to draw out a sample space or a tree for every single scenario because sometimes you got a lot of them and it's just going to make a big mess of spaghetti and you're not going to be able to decipher it. So the more important thing is, and it's what I've got here, we don't need to see all the outcomes. What we need to know is just how many there are of a particular outcome and event. So I'll show you what I'm talking about. All right. So two of the problems that we got involve permutations and combinations. Remember, permutations are when we have order. And what we've got here is we have a class that's got 7 people in it: Jim, June, Javier, Jane, Jorge, Jasper, and Jules. So we got 7 people with J names, which is just, to make it interesting. It's not, doesn't really mean anything other than that. Okay. So now they're in order. So what we want to use is we want to use our permutations. We're going to use our permutations. All right. So how are we going to use it? Well, here's what we're going to do. We are can see here, hopefully, there's only one pick that we got to worry about, and that is picking the 3: June, Jane, and Javier will be picked in that order. Now that's just one order, one pick. All right, so what we're going to do here is we're going to do this as such. All right, we're going to write out here 1/, and we're going to use our permutations here. This is our one pick right there, and it's in the numerator. Now, the permutations are going to go in the denominator for this one, since there's only one pick. And we're going to, from 7, we're going to choose 3. Okay. So that ends up being, let's see if we can get that little calculator deal here. I got to go over to the book and get it. Actually, I got to go to one of the assignments to get it. But that calculator does a good job for these things. All right. So let's go back to the notes here. And so we're going to use our calculator and we're going to find P3. And so that's going to be 1/210. So this one pick right here, the pick of June, Jane, and Javier, in that order, there's only one of those, so that's why there's a 1 up here. And the way that 3 can be picked out of 7 is given by this permutation, 7p3, and then that gives us 1 over 210. Now, let's say we want to do these without respect to order. All right, well, if there's no order, then we're going to go back to our friends, the combination. All right, the combination. So now it's one pick again. So the numerator is going to be 1, but now down here it's going to be 7c3. All right. So this should be a smaller number because we're picking the same amount, 3 out of 7, except now since we're not having to worry about order, there's going to be less of them. So let's do it. But it's always a good idea to have in our mind what we're going to be looking for. So we got the 7c3. So that's 1 over 35. Okay. So smaller probability here on this one because order is an issue. On this one, it's a larger probability. In other words, 1 out of just 35 because order does not matter. We can have those 3 people in any order. And it doesn't matter which ones they are. The names could change. You're picking 3, so that's your R. That's your small number. The total number that we had up here, the 7, is the big number you're choosing from. Now, you all right? You all right with that? Does that make sense?
Yes.
All right. Give me 1 second here. Oops. Okay. Just want to make sure I had all my stuff in order here. All right. So now, they're not always going to be one pick. Sometimes it could be more, you know. Let's look at an example. All right, here's one. Takes a little bit of thinking, but it's going to involve combinations now. And the reason why this one is combinations is because we're not going to have to worry about any order here. And this is the way it goes. It says a club consists of 5 women and 5 men and 7 women, 12 club members. 3 are selected at random to attend a conference. Find the probability that the selected group consists of 3 men. Three men. All right. So the way I like to handle most all the probabilities is I want to look at what the denominator needs to be. The denominator is going to be the large number. And so we're picking 3 people and we're picking them blindly because we can't choose which ones we're going to pick. We're just going and picking 3 out. All we need to find, or what we're going to have to find out is how many ways do we pick 3 out of 12? Okay, let me write this out a bit. All right. So 3 men, and we want the probability. And remember, probability will never be greater than 1. So that's why the big number's got to be on the denominator. So what's going to happen here is, all right. All right, so down at the denominator, we're going to have C, because we're not having to worry about order, because we're just picking 3 people. So how many are there to pick from total?
12.
12. All right, so let's bring up that calculator and do that part first. And oftentimes with some of these problems, you'll have like several problems to solve for this one. This one's only got 1, but some of them might have A, B, and C. But the denominator will be the same. So it's always wise, in my opinion, to do that first. All right, so what we're going to do is I'm going to do 12 C3, and that tells me that there are 220 different ways to pick 3 out of blindly 12 people. But these guys probably they want to find out, is it likely that it'll be just 3 guys going to this conference, so that way they can get up to no good stuff, because if they go with ladies, they have to act like gentlemen, right? So now, how many ways can we pick 3 and have them be just men? We want our 3 to come from where? We want our 3 now to come from 12. We want it to come from which one? 7 women or 5 men? If we want 3 men, what do they have to be picked from? The 5 or the 7? Hint, hint. The 3 gotta come from that 5, or else there's no 3 men. Okay? They gotta come from those 5 guys. So then that's what we're solving there. Okay? So now we're going to do 5 C3 equal to, and so what's going to be up here is 10 and now just simplify that. Remember, your fractions are always going to have to be simplified, so that's going to take off both of these divisible by 10, so it's going to be 1/22. So let's say we want to round this to hundreds. Let's round this to hundreds. Well, how would we do that? Calculator is always a good place to start. So how can I convert that fraction to a decimal value.
Divide it.
Yeah, you're going to take 1 and divide it by 22. And then that's going to give us this. And so we're rounding off to here. We're rounding off to tenths, hundredths. So we're rounding off to this second spot. So we go to immediately to the right. That's 5 or above. So it bounces this up to 0.05. And if we wanted to think about that as percent, we just multiply it by 100. But sometimes they'll ask you percentage wise. What happened? Let me just put it to 0.05 times 100. I don't know what I had in there. So if we multiply by 100, that'll give us percent. So this would be equal to 5%. And the reason why I'm converting to percent is the same reason that Alex in the book will do it. Because here's the thing is, people don't think very well in fractions and they don't think very well in decimals. But for some reason, people understand what 5% means. So that tells us right there that there's about a 5% chance, or it's actually less than 5% because we rounded it up. So it's less than 5% chance that there's going to be 3 guys going on this to this conference. So then that would give them an indication about whether they could expect this to happen or not. So provided that it's a free pick, in other words, it's random pick, nobody's cheating, they got less than 5% chance that all 3 guys are going. All right, questions? All right, let's see what else we can get into. All right. Now, usually people in school call this a combination lot, but mathematically speaking, it's a permutation lot because the order is important. And the reason being like 21, 5, and 13 is one combination, and 21, 13, and 5 is another combination. Hence, it's actually a permutation because the order is important. So all of these would be different as far as a permutation is concerned, but combination wise, all those things are the same. And there's actually even 3 more of them. But I was wanting to get you across the point that this right here, they call it a combination lot, but it's actually permutations because order is important. All right, so let's say a thief has 10 tries at opening the above lock. All right. What is the probability he can open it in those 10 tries? All right. First of all, let's handle this like the one that we did up here. Remember, we just did 1 over because it was 1 pick. So let's just talk about 1 pick first. 1 combination try. So we'll say 1 pick. Now, first of all, how many numbers are on this lot? How many numbers are on that lot? This is important.
39.
35. Oh, 40.
40?
All right, there's 40.
It's 40.
Because the way our numbering system works, and this is the same thing for those license plates, remember, you only got room for one letter in there. But since you start with a 0 or end with a 0, you got 1 through 9, and then throw the 0 in there is the 10th one. Well, it's the same thing as here. If you count going around 1, 2, 3, 4, 5, or we can just count by 5, 10, 15, 20, 25, 30, 35, 36, 37, 38, 39. And the 40th one is the 0. So we got to get that right about the counting to get the numbers correct. So then this is going to be, oops, I'm sorry, I hit, it's P, because it's permutations. So we got 40 numbers to pick from, and we're picking 3. All right. So denominator wise, all right, we're going to do the 40. We're going to do the C, and we're going to do 3 for the 3-number combination. And that means that there's 59,280 different ways So if we just got one try at guessing that combination, we're only getting one out of the 59,280 possible combinations for that lot. So for 10, all right, it's going to change it slightly. Well, maybe not slightly, but it's going to change it. It's going to put the odds, there's going to be a higher probability, but still. All right, so we're going to do the same thing that we did on this. We're going to put that P down there. So now what's going up here is a 10. We could also do the same thing by multiplying this times 10. It's going to do this the same thing. And the beautiful thing about the decimal system is, see, and that's why I did 10, because it makes this a little bit more fun. I don't say a little bit more fun, but all right. So let me put that 10 a little bit better here. All right, so if we divide both top and bottom by 10, again, since this is a decimal system, we're taking off 10 each, so that's what that 0 represents. So now with 10 picks, what happened to my thing here? All right. So it's 1 over 5,928 now, 5,928. So 10 picks does reduce it, but it's still, you're looking at almost 6,000 different possibilities. Whereas at the top, it was a little bit more than 59,000. Okay. So now, depending on how many times you're picking, it will change that numerator. See what we did here on this one, up in the numerator, we had that the 3 being picked from the 5 up there, because that was a subset of the denominator. And that was specific about what we wanted to have, the 3 men. This one is a little bit simpler in a way because it's just saying how many, what is the probability of 10 picks? Well, all that does is simply put a 10 up in the numerator. All right. Any questions? So we can look at also the, oh, you know what? Let's round that to thousandths, let's say. All right. So we're going to take the calculator, and as we did before, we're just going to divide the numerator of 1 by 5,928. So then that gives us, you know what? That's not even a good thing to round off. Let me put 10 thousandths, because let's do 10 thousandths for that one. So 10 thousandths is going to be, so that's tens, hundreds, thousandths, and 10 thousandths right there. So that's the one we want to find out whether it stays or goes. It's going to stay if the number immediately to the right is below 5. It's not. That means we bumped up this to 2. Hundreds, thousandths, tenths, hundreds. There we go. Make sure I got it right. So there's 3 zeros, and the 1 gets bumped up to a 2 courtesy of the 6. Okay. There's going to be rounding in these probability problems, so pay attention to what they're asking. Sometimes they'll say simplified fraction, lowest terms. Sometimes they will say round to a given decimal place. They may not always say 10,000. They might sometimes say the 4th decimal place or the 3rd decimal place. So pay attention, because that is a big part of getting these right, because it's not always the same. All right, let's talk a little bit about the lottery and how that works. The lottery, we don't have to worry about order with the lottery. So the lottery is going to be combinations. Combinations. Okay. So no order. No order. So not ordered. Okay, so that's why we're using combinations here. I've mostly got this worked out, so I'm just going to fill in the blank. Now, what this is, it's a Powerball kind of scenario. So the way the Powerball works is you have the state lottery, which is picking 5, and that's what this is here. The 5 picks, and the numbers are 1 through 69. Now, the way that this is going to work is we're going to first find out this part. And so that is 11, and then that's, we're using the, I just noticed something here. I don't know if I can. That should be up there, a 69 factorial. All right. And then down at the bottom, it's 69 minus 5, which is 64 factorial. And then we're just using the calculator to do it. If you're one of those people that likes to do it by hand, by all means, I'll even help you. It's just that I'm just trying to do things the most expedient way at times. So that's 64. Well, anyway, I'll just show you on the calculator how that 11 million comes out. All right, so we got 69 picks. We're using the combination because order's not pointed. We're picking 5. So there's the 11,238,513. All right, that's what that is right there. Okay, now we're not just doing the regular old lottery. If we were just playing the state lottery in this scenario, there would be 11,238,513 ways to pick 5 numbers. All right.
If only that would be true that we could win $11 million.
Yeah. Well, that takes a lot of Liberty mathematics, because what that is saying is there's 11,238,513 different picks. Okay. So that means in order to hit, you got to pick the right one, because there's only going to be one of them. Now, there could be 2 people with the same one. I'm sure you've run across that, but still, the number wise, as far as the picking the number is concerned, you're picking from 11,238,513 possible ones. Now, so if we just do the pick 5, that's 1 over that 11 million number. And so just to kind of show you what that decimal looks like, because the decimal is a little bit easier to understand than the fraction. So let's say 1 divided by 11,238,512, and then I'll take out all the rest of the stuff here. So see, what happened? 1 divided by 11,238,513. I got what? 1 divided by so see, look at how many decimal places there are. That's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, and so forth. So that's way down there. So that's a small probability. As a matter of fact, that probability is very small, and you can kind of see by the number of decimal places. All right, but we're not done there yet because we're talking about the Powerball. Okay, so what happens then is we're going to take this 11 million, and so in order to win the Powerball, you got to have the right one of those 26 red balls. So there are 26 of those. All right, so that takes the 11 million. And then we're going to multiply it times 26. So see, that's how we get this 292,201,338. So that now translates out to not quite, but I think the population of the U.S. is like 330 million. So you're getting close to there being one possible number for everybody in the country. Okay. So now, probability of one of Powerball with one ticket so that's 1 over, and then the number down there 292, 201, 338. And then if I do that with the calculator, just to show you how small that is, so, and this is without order. So see that, look at all those zeros. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millions, 100 million. So that's 300 millionths probability. Okay. So this, the Powerball, and this lotteries in general are a good use of combinations. Good use of combinations. That's when combinations are used because there's no order involved. So here's another one that's a different kind of lot. It's still same principle that you're going to get your numbers in order. All right. A different permutation lot has letters A through L on it. And I think I've seen some of these that do have letters. And the combination consists of 4 letters with no repeats. All right. So how many letters is that? That's 12. Because you got A is 1, 2. See if I can do this. So 5. So that would be A, B, C, D, E. F, G, H, I, J, 10, K, and L gives you 12. So we're picking 4 from 12. So that's going to be, we're going back to permutations now because the order is important, and we're picking 4 from 12. And then calculator business. Let's find that. So 12 P 9. So let's see, what is that? That's that's not, what did I do? Let me make sure. Oh, I think I put 9. It's 4. There we go. So 11,880. So that's the number of permutations or combinations for vernacular. 11,880 different possible codes. All right. But we want to find out a specific scenario here, and this is where we got to pay a little bit of attention. So our denominator is going to be this. So let's see. Probability of, and we're going to just put I, J, K, L. What we're looking for, and this is kind of strange, but it is the type of problems that you get, is we want to use I, J, K, and L only in our combination, and we're not worried about the order. All right. In some order. Now, it's not saying that we're not worried about order and that it's combinations. This is still permutations, but they don't care what those 4 things are ordered. So what we're going to do is, in our numerator, we're going to put four P4. So our 4 codes now, or our 4 letters in our combination code, are limited to these 4. So we're picking 4 from 4 permutations. And then the denominator is this right here, the 11,880. All right. So let's do that on the calculator. The 4P4 gives us 24. So this is 24 over 11,880. All right, so let's go ahead and take that and this round to the. Well, let me go ahead and do it, and then I'll say we'll round it to. So 24 divided by 11,880 would give us this. So let's round to the tenths, hundredths, thousandths. So the thousandths. So tenths, hundredths, thousandths. So 2 thousandths would be the probability of this if we limit those codes to just those order. All right, any questions?
No, everything's okay.
All right. So let's get rid of all this. And then we got a store has 6 different fitness magazines and 3 different news magazines. So it has 9 magazines total, okay? 6 fitness and 3 news. All right. They don't tell you 9 there, but we need to know that. All right. And then asking, and a customer is going to buy 3 magazines at random. Find the probability that he'll pick 2 fitness magazines and 1 news magazine. Well, first of all, let's do the denominator, because the denominator is usually the simplest one. So probability of 6 fitness and 3 news is in the denominator. We have 9 magazines. That's where the 9's going to come in now. And we're not worried about order here. We're just worried about whether he's got the magazines or not. So it's C. And how many are we picking?
Two.
He's picking 3, right? You're going to use the 2 next. So keep that. All right. Now. Now, in the numerator now is where we got to take care of this 6 fitness and 3 news. All right, first of all, how many fitness magazines are there? All right, so this is what this is going to be. This is the fitness. We got 6 of those to choose from. How many do we want to have? This is where that 2 comes in. Our 2 magazines, fitness magazines, has to come from the 6 total fitness magazines. Now we're multiplying, because that's what and is. That means multiply, and. All right. Now we're picking 3 from 3 news magazines. We're picking 1. So there's 3 total news magazines, and we're picking 1. So up here, this is the fitness, and this one over here is the news. Okay. So let's do the denominator. And incidentally, there'll be some of these that'll have like a list. I'll try to do one in a little bit to show you, but the denominator will stay the same for all of them. So 9C3. So that's 84. All right, and then up here, we're going to have two numbers. We're going to multiply. Okay, that's our multiplication sign. That's not very good.
Can't see what you're doing. We only see test chapter 2.
What?
I can't see what you're doing.
What's happening?
It's showing test 1 chapter 2 is like another assignment you have there.
I mean, I'm seeing this on all my two screens. Refresh your
Yeah, it looks
session.
fine to me.
Sorry, never
Yeah.
mind. Sorry.
Yeah. Because sometimes I notice that'll happen to me. Because like I said, I got two screens that I'm actually got three. I got the laptop I'm working on, and I got one for my audio, and then one for the video. And so I can see what y'all are seeing. And sometimes one of them will freeze up. Like I said, it'll just slow down. All right. So now on this side, it's 6C2. So that's 15 here. And then the 3C1 is going to be just 3. So that's 45 over 84. And then we'll round it off to we'll do like tenths or 100. Let's do hundreds. So 45. So that's tenths, hundredths. So that would be 0.536. Because the 5 is getting bumped up. So there we go. All right, let me go over to the book, and we'll do one more over there that's got a couple of parts to it. So we're going to go over to 10.5. And then look at the applications there. There's one that's saying. Let's do this one that's just got 4. We should be able to do this pretty quick. All right. So what I want to do for all of these, we're going to have the same denominator. Let's read the problem. A student faculty government committee of 4 people is to be formed from 25 student volunteers and 5 faculty volunteers. So there's 25 total. Because it's 20 plus 5, okay? So now we're picking 4 from 25. So this is the N, and then this is the R. So our denominator will be denominator for all problems is as such. It's the C or 25. And that'll save us a little bit of time because we're just going to do it once and then we just do the numerators. All right. So what does that come out to? Oh, I got it backwards. What am I doing? It's and this eraser doesn't just erase. There it goes. Oops. So 25 and 4. I had it backwards. Big numbers always got to go first. And then you will find out on some of these if this number is bigger than that one, it'll end up being 0 because you can't do it. It's just the 0 ways to do it. So like if I were to put in 4C 25, see that 0, there's 0 ways to do it. But anyway, it is 25 C4. So that means there's a 12,650. All right. So that's the denominator for all of these. So let's get busy on this. So for all faculty members, that means that the 4, and I'm just going to put the numerator here, all 4 have to come from 5. So then this is 5 C4. So this is 5. This is 5. So our probability is 5 over 12,650. I'm not going to worry about rounding them off yet, just for the time's sake, because I don't want to keep you all in here. And I might not even be able to finish these. Okay. I want to do, I'm just going to do the numerator for this next one. So this is all students. So the numerator, the 4 has to come from 20. All right. Now, for this last one, it's very much like the one that I just did with that, the magazines. It's got an and it's the same thing with this one. So we got to do the one faculty member. So we got to do, we want 1 to be picked from 5 times the 3 to be picked from 20. So whenever you have an and in there, that means that your numerator is going to multiply. So let's see if we can just do this all in one fell swoop for that last one, and then that'll be enough. So up in the numerator, and this is a good thing about this calculator and Alex, it allows you to stack these things. And then we're dividing that by the 25. See, which we already know is 12,650, but I just wanted to see for you to see how it looks. So the Alex calculator always going to give us in decimal, so that'll be enough. So then this is equal to 0.451. So the thing I wanted to stress here is just when you got an and, it means you're multiplying. So for this one in the numerator, it would be The 2 come from 20. That's the student ones. And then this would be the 2 from the 5. And let me just show you again. And then down here would be the 25. And I'm just going to show you this pattern, so maybe it'll help you set it up. But see, the 2 and the 2 add up to be the 4. So the 2 and the 2 add up to be what the the denominator is down here. Same thing on this, on the left-hand side for your n. 20 plus 5 is 25. So if you've got that pattern in there, you should have that set up correctly. So let's just do that last one real quick with the calculator, just in case. So it's 20 C2 times the 5 C2 divided by the 25 C4. So then again, let me just explain this. In the numerator, you've got the 2 things you got to deal with. So the 2 students from the 20. 2 students come from the 20 student volunteers. The 2 faculty members come from the 5 faculty members on that committee. And then the denominator is the 4 being picked from all of them blindly. And so 0.150. All right, so that's enough for today. If you got anything, stick around. I will see you on